This is part of a solution to problem 9.1.29. It is similar to exercise 5 in homework 3. This is a proportions problem. How can we tell? It says that 362 out of 2,293. So that's a proportion. So many out of so many. The problem has 4 parts. Part A, obtain a point estimate. The hardest part about that is understanding the term point estimate. The calculation is really easy. Then we need to construct 2 different confidence intervals, one at 95% confidence and one at 98% confidence. I'll do parts A and B in this video. First, let's look at some theory. This is a proportions problem. We have 362 out of 2,293. A confidence interval always starts with one estimate, called the point estimate, and it's an interval. This is a confidence interval. Intervals go from one number to the other. Goes from a lower bound to an upper bound. For the point estimate, that's our best guess. If we measured 362 out of 2,293, our best guess for the percentage would be 362 over 2293. Our best guess is exactly what we measured. Then the amount to go up and down would be a normal critical value, so a number from the normal distribution times the standard error. The normal distribution number depends on the percent confidence we want, and the standard error is the formula square root of p, 1 minus p over n. Let's do some calculations using Excel. This will be for parts A and B of the problem. To get to a confidence interval, what we want to do is to calculate the standard error. For proportion, the standard error is the square root of p times 1 minus p over n. That's what we want to compute. So what's p? The proportion of successes. That's 362 over 2293. This is also the point estimate. This is our best guess. If I were to ask you what percentage of people have at least one tattoo, you would look at your study and say, my best guess is 15.8%. Your best guess would be whatever your experiment measured. Let's do the other items now. 1 minus p, that's equal to 1 minus, and I'm going to click on the cell. That's a lot better than typing in a number and rounding. I need p, 1 minus p, and n. N is the number of adults, 2293. Now let me just calculate p times 1 minus p over n. p1 minus p over n, that's equal to p, I'm clicking everything, times 1 minus p divided by n. And each time I'm clicking on the cell. So that's p1 minus p over n, and the standard error is the square root of that, equals sqrt, the Excel function for square root, and I'm going to click that number. So the standard error is 0076144464, etc. Now, for a confidence interval, we need the normal distribution, a normal number of standard errors. For part B, we want a 95% confidence. So 95% confidence is 2.5 cut off the left and 2.5 cut off the right. If we cut off 2.5% on the left and 2.5% on the right, we end up with 95% left in the middle. So we need to compute the critical value that does this from the normal distribution. To do that, it's norm S inverse. That's the Excel function for calculating critical values from the standard normal. The S in there stands for standard, and put in the probability, 0.25. So this is a negative number. Usually we use positive numbers for critical values. So I'm just going to say equals negative that. So now I have a positive number. I can decrease the number of decimals, and you can see that we have the usual 1.96. So what's the lower limit? Is the point estimate minus the normal times the standard error. And the upper estimate is the point estimate plus the normal times the standard error. So the lower equals the point estimate, P, minus the normal critical value times the standard error. So it's B2, which is the point estimate, minus B10, which is the critical value from the standard normal, times B6, which is the standard error. 0.1429477, etc. In the upper, the same thing, is the point estimate plus the critical value times the standard error. The same formula, but with a plus instead of a minus. So this is the confidence interval. Since the problem asks us for 3 decimals, I can use the Excel rounding to 3 decimals, and the confidence interval, 95% confidence interval, is 0.143 to 0.173.